question where where the lines intersect have an actual meaning to them, where the lines intersect have a meaning to them. And that meaning to them is what's the value in the whole thing. So, like yesterday when we were talking about it, the intersection told the time within the race and the miles within the race that the friend who had started at the finish line finally caught up to the dog sled team and was able to offer support to the dog sled team, right? So that was what was happening yesterday. Today, we're going to be talking about money. We're going to be talking about George and LaTanya, and we're going to be talking about they both want to save. They both want to save for the same thing. They're each saving in a different way. They're each saving in a slightly different way. So we're going to be looking at that. Okay. Now, we have to go ahead and look at what kind of information is being told to us through the words. Through the words. So we're going to pull off of the words. Let's put our name on it here, right? Mrs. C. Period 3. Okay. So we're going to pull out of these words the information so we can start figuring out what's going on. We have LaTanya, okay, and we have George, okay, and they told us some information about LaTanya and George, right? They told us that how much they opened their savings account. They told us how much they're going to put in the savings account each week. Okay. So if we're thinking about our equations and how we build equations and stuff, right? What is the format for equations again now? What does our format look like for our equations? Yeah, y equals mx plus b. So they must be telling us, some information to build equations, okay? So they must be giving us, some m and some b, okay? All right, so we need to look at how are the words telling us whether it's a beginning or whether it's a slope. So we have beginning, right? Oops. Which is what letter in our equation? Our beginning in our format. What's our beginning letter? B. Okay. And they told us how much they're putting in the account, right? Each week. So what would that be? The savings, the amount they're saving, what would that be? Saving is their growth, right? So that's going to be their M. All right, so we're going to put in a little summary thing that information for the two of them side by side. Okay, do we get that? That information side by side. So what is LaTanya's beginning? What is LaTanya's beginning? LaTanya's beginning at 50. Okay, so under LaTanya, I'm going to say 50 across from where it says be the beginning, right? What is George's beginning? 75. So Latanya's beginning at 50. George is beginning at 75. I am intentionally color coding them 2 colors, okay, because we're going to be ending up graphing them, and to have them different colors makes it more helpful. Okay, so what is Latanya's growth? According to the story, how much is she growing? 30, right? Okay. According to the story, how much is George growing by? Someone other than Marissa needs to be answering if they want their participation points. Okay, 25. Told us he's adding 25 each week. Okay, so we can get their equations now, right? We have an M, we have a B, so we can get their equations. Okay, so we can get their equations. So let's get their equations. Okay, so what would Latanya's equation be? Remember our format, y equals mx plus b. What would her equation look like? Y equals 30x plus 50, because we put our n where it belongs, we put our b where it belongs, we made the equation, right? Okay, what about for George? I'm going to move George over. George is 25x plus 75. So it's almost the same. I'm just going to take this one and tweak it a little bit, right? Because it's the same format. Y equals mx plus b. But he's 25, numbers block, and 75. Yeah? Is everybody comfortable with that? Anybody not understand that? We've been doing that for a little bit. Is everybody good with that? Okay. So we are going to use those and make a table of values. Okay, we're going to use those and make a table of values. So scroll to the bottom, add the page. We're making our table of values. Scroll to the bottom, add the page in. We're making our table of values. Okay. And our table of values is going to have our X column, our Y column, and our equations in the center. So let's get our lines. Latanya was red or blue? What color did I make Latanya? Red. Okay, I'm gonna make her table in red and his table in blue to keep the color coding going. Okay, does that make sense? Okay, so This is my table for Latanya. Except that should be red letters. Red letters, maybe. And then we have our X. Yes, I am making it a different color. And I'm making, this should be a red one. Remember, all I have to do is click on it to change it. And then we have our equation in the middle. So I'm going to go up to the top and get that equation. And that equation was y equals 30x, or y equals 30x plus 50, right? Okay, and then the y goes in the other column. Here goes y. Now, I'm going to go make George's in blue. So let's go get our lines. This is no big deal stuff, right? Okay, put my y here. So what I'm doing is I'm going to have the coordinates, the x and the y are going to be the color. The x and the y are going to be the color. And so that they match with the above, the work is going to be the opposite color. So this one was y equals 25x plus 75. So they're saving. And would we use the normal stuff? Would we use the -1, -2, that kind of stuff? I want these tables down on a new page, so please do not draw them below the graph. Go add the page at the bottom, put the tables in. It's sitting here for a while. You can get it done. I use the shape feature for the lines. I use the equation feature for the parts. Don't overthink it. So we can't use -1, -2, 0, 1, 2, because does it make sense to have -2 weeks? Because the X stands for weeks and the Y stands for money. So this X is standing for weeks and this Y is standing for money. So it doesn't make sense to be using negative numbers for X because there's no such thing as negative weeks and there's no such thing as negative money, sort of. Negative money is when you borrow. Okay. So in the real life situations, when we're doing these table of values, yes, you're not going to be able to do -2, -1, 0, 1, 2. You have to think about would they make sense for the situation. And having negative weeks doesn't make sense, right? Having negative weeks doesn't make sense. So we're not going to use negative weeks. We can use a 0 week though. We can use a 0 week because that's when they start. And then we're going to do 5 more points after that. So what would I do for my next week? It's up to us. We get to pick our X's. What do we want to pick for the next X? Okay. How about our next one? Okay. So do we want to just go 1, 2, 3, 4, 5? Because it's weeks? Sure. Okay. Okay. Now we are using those same numbers for both tables. We're using those same ones for both tables. Okay, so I'm going to go up here and I'm going to copy the numbers I chose for this table. I have to use in the other table, so I'm going to go copy those. And I'm going to paste them over with the other table and change their color. Okay, I'm going to paste them over with the other table and change their color. Okay, so I need to change up the color of these because I want them to be different colors on purpose. Because I want to be able to visually see the difference between George and Latanya. Because we will be graphing it. Okay, so whatever we chose for the first table, we have to use for the second table. All right. Now, we use the X part of the equation, right? So copy, paste it down below. What piece of this are we going to change? And what are we going to change it to? What piece of this are we going to change and what are we going to change it to? Okay, we're going to change the X to whatever the X is that's to the left, right? Okay, so then we're going to, that same thing is going to happen on every row, right? So we're going to copy that and we're going to put it down on each row, changing that parentheses to whatever the X is that's to its left. Correct? We've done quite a few of these. This should feel very familiar. Right? Okay. So I'm going to go do it. I'm going to go do the copy, paste, change. You don't need me to say that out loud all the time. You guys should be comfortable with that by now. Okay. So I'm just going to go do the copy paste part and change it up to the X that's to the left. I'm not solving any math yet. I'm just putting the format stuff in. And I'm going to do the same thing with the other table. Okay, get the format stuff in. I am purposely making it so the work looks different than the coordinates. It's up to you if you want to do the same thing for yours or not. I don't expect. Okay, so I'll copy this guy. Because there are a lot of people that are visual, and by doing it color coded, it helps a lot in the understanding. So I'm doing the color coding on purpose to separate work from coordinates. Okay, that one's going to be red. All right. So I am just doing formatting. I am not doing any calculations yet. I'm doing just the mechanics of it, the copy and the paste and the shift and all that. Last format, and then we're going to go do the answers calculations. Okay, so, right, we are now going to go do the math part of it. We're going to solve the 30 times, the 30 times, the 30 times, and add in the 50 and figure out what the y's are going to be. Okay, 30 times 0, what's it going to be? 0. So this is going to say 0 plus 50, right? Okay. Okay. So that still equals 50. Now we're going to go do the next one. 30 times 1. But it says we're supposed to add 50 to that. So what are we going to do? Okay. Someone else answer. What's the next one going to say? 60 plus the 50. Christian, enough. Let others try. Okay. What's the next one? 90. Thank you, Princia. Plus the 50. So what are we going to say? Okay. So far, so good. Someone else other than Marissa or Christian. What's the next one going to say? 120 plus. So what are we going to get? Okay. How about the last one? Other than Marissa and Christian. 150. Oops. I have to plus the 50. So what are we going to get? Okay. Now we're going to go do the other table. Okay. Someone other than Marissa and Christian and La Princia. What's the first number going to be? 25 times 0. It's going to say 0 plus 75. Thank you. And that gets me 75, right? This is going to be blue. 75. I said blue. Okay. Someone other than Princia, Marissa, or Christian. What's it going to say? 25 plus 75, not 4. What's this column over here going to say? This Y is going to be worth how much? 100. Okay, keep going. What's our next one going to say? What's our next one going to say? Too many people are hiding in those cameras. Come on. I should see your eyes at all times. What's our next one going to say? Do the math. Get your cameras fixed. What's this next one going to say? Someone do it. The 2 times the 25 would be what? Okay. Okay, so now no Princia, no Jamie, no Marissa, no Christian. Someone else needs to start taking over. How much would that be, Jamie? Because you had told us that it was 50 plus 75. Let you finish yours. How much is that, Jamie? Yeah, it's 125. So close. Because remember, 7 plus 5 is 12. Yeah. Okay, so no Jamie, no Princia, no Marissa, no Christian. Someone else take over. What's this next one going to be? The 3 times the 25 would be what? Thank you for those who were participating. I appreciate it. The 3 times the 75 is what? Come on, guys. 3 times the 7, 3 times the 5, 3 times the 25 is how much? You guys know how much 3/4 is worth. Don't tell me you don't. Okay, so we would say 75 plus 75, yeah, because 75 from the 25 and 75 from where he started. Okay, if I have that, 75 plus 75, what's it going to total up to? And you guys can be using your calculator, so I don't know why you guys are afraid of doing regular math. 150. Okay, how about the next one? Do the math for times the 25. Got a couple people that are about ready to go because you're not listening and fixing your cameras. So yes, 100 plus 75 gets us what in the Y column? 175, thank you. Okay, so last one. This should be a 5, right? What's it going to be? What's going to come out to be? 125 plus what was already there? So what are we going to get? 200. Now, we got to make the pairs. We have to make the pairs. Okay. Shouldn't see any cameras off. I should see eyes in every camera. Fix that, please. Okay, so we're going to make our pairs. We're going to make our list of pairs. Remember, we take the X and we take the Y, and they make a pair. So our first one for LaTanya was her 0, 50, where she started, right? In week 1, how much money did she have in her account then? What does it say on the table? 80. Okay. So we're just pulling the two pieces that are red into the parentheses of the coordinate, okay? So you're taking the red from the left and the red from the right and pulling them together, which is why I kept them the same color, okay? So 2 was with 110. 3 is with 140. 4 is with 170. And 5, oops, parentheses, 5 is with 200, okay? So that is why I kept them the same color, so that they were easily pulled together into their parentheses, okay? Now, did we use the same X's for the second table? Yes. So I'm just going to copy the list we already have. I'm going to copy the list we already have over. And I'm going to change the Y numbers because those were the different part, but the X's were the same. George did not have 50 at the beginning. He had 75. Oops, sorry. His first week, he had how much? His second week, he had? Okay, so all I'm doing is changing these to George's numbers. That are the Y column of his table of values, 5,200, okay? Because work smart, not hard. You don't have to retype the list if the X's were the same. You just have to change the piece that was different. Okay, now we need these tables up above so we can graph. So I'm going to take this table of values right here, copy it, Control C, just like normal. And I'm going to come up onto the first page below the graph and paste it. But LaTanya is red, so I'm going to change her color to red. Okay, I'm going to change her color to red. Okay, I'm just moving a copy of it up here. Okay, then we're going to go down and get George. Copy it and move it up there with LaTanya's. Okay, because we need it on this page. We just needed more work space. Okay, that's all we did. We just created extra workspace down below. We know that the red is LaTanya, right? And, oops, that's red. That we know the blue is George. So I'm just labeling to remind myself what these lists stand for. The red list was LaTanya's information from the table, so we can graph it. The blue list was George's information from the table, so we can graph it, okay? Okay, now, I'm just putting it there for the minute. They said they wanted us to figure out where their money was the same amount. Have we figured out when they had the same amount of money in their accounts? Do we know when they have the same? When? When did they have the same amount of money in their accounts? At what week? At 5 weeks. Well, how do we know that? How do we know they both had the same amount of money at 5 weeks? What do we visually see happened? What did we visually see happen? The table of values had the exact same numbers at the exact same spot, right? So that was one way that we solved. The other way is the graph. So let's go get the graph. I have to change this down to a smaller. No, I want this to be this because I'm graphing, but I want to be red. I'm getting LaTanya. No, yeah, okay. So first thing, we have to label our graph. We have to label what the directions mean. For our graph, what did the X's mean on our table? What word is with the X? Weeks. What word is with the Y? That we just use symbols for. What is the money? Okay. So we have to go label the pieces of the graph. So this bottom is the number of weeks, right? And this up and down line is the money in savings, right? Now we have to figure out what does each line stand for on our graph. We have to find our scale. We have to find our scale. Okay, so can we go by ones for the weeks? Do we have enough space in lines to go by ones for the weeks? Yeah. Could we skip lines and have it equal 1? Do we have enough space to do that? 1, 2, 3, 4, 5. Looks like it, huh? 1. So let's use our lines. Nope, I don't like that. 1 second, I have to fix it. Use this guy. So that could be week 1, week 2, week 3, week 4, week 5, right? And we have to keep labeling. So how far out in weeks would we actually be going if we were going to do the whole graph? Yeah, we'd be going 7. So 7. So that people know that our dashes mean ones. Now we have to figure out these Y's, this money. Can we go by ones? Can we go by ones for money? No. Darn it. Because that'd be 300, that'd be 200 lines, and I'm pretty sure that this is not 200 lines. That's not 200 lines, I'm pretty sure. How many lines do we have to work with? How many lines do we have to work with? $15, and we need to get up to at least $200. So can we go by tens and still make it to $200? No. So we might have to go by what to get so we can make it to $200? We might have to go by 20s, yeah. Okay, so we might have to go by 20s. If we go by 20s and we use every line, how high would it go? How high will we go if we go by 20s? Okay, to 300. So we have to write 300 at the top. Okay, so let me go get my lines. 20, 40, 60, right? Put your lines in. Don't worry that they're not perfect. As much as possible, you're trying to make them on their lines, but even as you can see, I have some challenges as well. I get it. I get it. But you got to move past letting it overwhelm you. Okay, and we said that that would be 300 when we got up to the top because we're going by 20s. You have to label your scale. So when someone looks at your stuff, they get it. They understand what's happening. They understand what's happening, okay? So that in mind, we're going to go put the coordinates that we brought up from down below onto the graph, and we're going to connect them to see where they cross. And we're going to see if where they cross matched what we thought for our table of values, okay? So change over your drawing feature to make sure it's a 4. So I'm in my drawing, I make sure it's a 4. I'm doing LaTanya first, so I'm red. At 0, she was 50, and each of these is 20. So 20, 40, 50 would be halfway between, right? At 1, she's 80. So 20, 40, 60, 80. 20, 40, 60, 80, 100, and halfway between. Okay, so I'm not going to talk anymore. I'm just going to put my dots. Remember, every other one's going to have to be in between because it's 70 or 110. It's in between a 10 and a 20. Okay, and this is 200. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, we're going to connect them with a red line because that's LaTonya's. Okay. And we're going to go copy and paste LaTonya's coordinates next to their points. So copy, but I'm going to make sure they stay the same color. So I got to switch this up. Keep Latanya's coordinates red if you were doing it color coded. Otherwise, don't worry about it. So I am just literally getting the coordinate, copying it, pasting it next to its dot. There's not, it's just copying and pasting. Okay. And I'm going to repeat the process for George's coordinates. So back here, I'm now blue, 0, 75. So this is 20, 40, 60. The next one would be 80, and 75 is close to 80. So I'm going to put it just a tiny bit below the 80. More than halfway, but not all the way. The 75 is not quite 80, right? Then at 1, it's 100. So that's easy. 10, 20, 30, 40, 50, 60, 70, 20, 40, 60, 80, 100. From that point on, it was only the 75 that really, each of the ones that say 5 at the end are going to be almost, but not quite on the line. Okay, so 2 was 125, so I know this is 100, this is 120, 125 is a little bit of that. Three is 150, so that's going to be on 20, 40, 60, 80, 100, 20, 40, 150. 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. I don't want 200, 180, 175. So these two get super duper close together because, but again, that blue dot should not be on the line because the line is 180. The line itself is 180. So I got to be a little above the red one, but not on the line. Okay. And then 5 for 200. So this would match. And I'm connecting with my blue line. The blue dot. And we're not stressing that it's not totally perfectly, okay? Because it's really hard when you're estimating to get it perfect. And it's okay. It's okay. Did they cross at the same place we figured they would? Yes, they both crossed at 5, 200. So we're now ready to answer their question. We graphed it and we made table. Okay, we graphed it and made table. So now we're going to answer their question. When will George and Latanya have the same amount of money? So we're doing our sentence answer because it's a word problem. Who are we talking about? Who are we talking about? Who are we talking about? Who's this about? Who are we talking about? George and Latanya. What about Lord George and Latanya? Tanya. Latanya and George. What were we figuring out for them? We'll have what? Latanya and George will have what? What are we figuring out then? Okay, we'll have what? What will they have? How much money? When? $200 at 5 weeks. 200 will have $200 in their savings at 5 weeks. Because they wanted to figure out when would they have the same amount. And you would need to tell them the amount. So we found that by creating the equations so we could do the table of values and using the table of values so that we could go ahead and make the graph. Okay. Okay. So says if you haven't done so already, make the equations. Did we make the equations? Heck yeah, we did. So I'm going to just copy and paste what I already did. I'm not going to make a new one. I don't need to make a new one. I have one already. Okay, so I'm going to copy what I did for Latanya down to Latanya's rule because we already made that rule. That's how we got our table of values. If you haven't already done so, make George's equation. Okay, so let's get George. And copy George down below into George because we did make the equations already. See, it says we haven't already done so. Well, we did. So we just get to copy it. Now it says, use the rules to check your solution. This is what they mean. If we want to see when they are equal, then we're going to take the two rules and make them equal. So we are going to say, when does 30x plus 50 equal to 25x plus 75? Because we want to find when they're equal, okay? When they're equal. And we're just going to do our normal math we've been doing. We're going to do our big zeros and our big ones to it to figure out what was the x, what was the week that it would happen. So when we're doing our big zeros and our big ones, we always start with our letters. We move our big letter, our little letters to our big letters. So who's going to move and how are we going to move them? Who's going to move and how are we going to move them? Yes, we are going to subtract 25x from both sides because 25x is smaller than 30x, right? And we need to move small letters to big letters. Okay, we need to move small letters to big letters. All right, so I'm going to subtract that 25x from both sides. Minus 25x from 30x. Doing the same thing on the right, so I'm going to copy it over. Work smart, not hard. Copy and paste what you can. Saves time. We know that we made this 0 out. Now we have to do the math on that left-hand side. Solve it up. What are we going to have now? Solve the whole thing. Make the whole thing first. What's it going to be now? Yes. 5x plus 50 is going to have to equal what? The 75. Okay. Are we done with our big zeros? Have we gone ahead and handled all the addition and subtraction? Have we handled all the addition and subtraction? Okay, so we need to move the number now, right? We need to move the number. We need to move the number. So we move the number away from the letter. So we have to get this 50 away from the 5x. So 50 has to move away from the 5x over to the other side with the 75. So what are we going to do to make that happen? What are we going to do to make that happen? We're going to subtract 50 from both sides because that'll make that positive 50 on the left turn into 0, so it doesn't matter anymore. Okay, because we need that to happen. We need to make the big 0. We need to make, because adding and subtracting 0 doesn't change our answer. And that's what we're trying to do. Create that doesn't change our answer moment. Okay, so simplify it. What would we have left? 5x equals 25. Yep. All right, so 5x equals 25 because 75 minus 50 is 25. I have run out of space. If you have not, it's fine. I'm just going to have to move it up over here. So it's not done. What do we have to go for now? What do we have to go for now? We have to create our big one by moving the stuff with the letter away. So what's with our letter that needs to go? That 5. What is the 5 doing right this moment? Okay, it's multiplying. So if we want it to go, what do we need to do to make it go? We have to divide, yes. So we have our 5x divided by our 5 and our 25 divided by our 5. And that made the big 1. This 5 divided by 5 is 1. And when we multiply, multiplying by a 1 doesn't matter, so it's gone. So we have an x equals what? 5. 5 what? 5 what? What did the x stand for? Weeks. This shows that they would be the same in 5 weeks. Okay, and that's what we were looking for. When are they the same? Now, our solution, though, that doesn't end our solution. We have to figure out how much money. So even when we do it this way, the algebra way, we still have to go take that 5 weeks back to one of the beginning equations to figure out the money. We don't get the bonus of the table of values. Okay. So our equation, doesn't matter which one we're using, our equation was y equals 30x plus 50. And we have to show that this 5 weeks creates the 200. Okay. So when you're solving it this way, with the equations only, you have to take what you find for when they're equal, and you have to plug it back in to find out the other guy. You have to find both the x and the y. Okay. Now we did this on our table of values, so we know the answer to this because we did it on our table of values. But if they do not tell you to graph, you could use this method. If they do not tell you to do a table of values, you can do this method where you set them equal, solve for the first, for the x's, put it back in to figure out what the y's are. Okay. They would have the same amount in 6 weeks, $200. Oops. Okay. Okay. So if you do it by setting the equations equal, you still have to take that x that you solved, put it back into one of the equations to figure out what the y would be. You have to have 2 pieces still. You have to have 2 pieces still. Let me see, did we finish all this stuff? Sort of. Did the graph scenario show in number did the graph scenario in number 32. We graphed it, right? Now, consider the questions. We went ahead and we answered these questions on the graph. We now need to answer them here. What did the X's stand for? What did the X's stand for? What did we say? So I'm going to go copy what I already said, because now I'm answering their questions. I just had put it on the visual. I didn't put it in their question. Okay. So I'm copying that the X is the number of weeks. So the X's are the number of weeks. X's are, and then boom, copied it. Y's are, what did we say the Y's are? Oh, I'm going to go get what I said. So I already did it. I'm just going to put it up with the questions they're asking. Amount and six. What did we decide the X's should go by? Because that's scaled. That's what scaled means. No, what did we decide by how many numbers? Did we go by 5s? Did we go by 10s? Did we go by 2s? Did we go, what did we go with for the X's? X's are scaled by 1. What did we do the Y's are? Y's are scaled by 20. Yeah. So we're just telling in a sentence what we did on the picture, okay? Should the amount of the savings should the amount of savings be graphed on the same set of axes or separately? Now, if we're trying to find out where they're crossing, we need them on the same set of axes, right? And isn't that, we were doing that. So we need to be having them on the same set of axes if we're trying to find out where they're crossing. They should be on the same set of axes. I'm just using the words right there. Because we want to see where they cross. Right? Because where they cross is where they're the same. I see a couple cameras. Maybe fix these. Okay, because where they cross is where they're the same. Okay, so we've answered all those. We've answered that. We've made the graph. We're done with this one. Now on this one, he already made the table of values. We don't have to do that. We're looking at his table of values to see. Okay, we're looking at his table of values to see. So examine his tables. Is there a common point that both rules have? Is there a common point that both rules have? Like on our last one, was there a common pair on the graph that we could circle, like we circled this? Oh, up here, sorry. Remember how we had this common point right here? This common 520, 5200? That's what we're looking for on his. Is there a common point on his two tables? No. So we have to answer that part of the question. There is not a common point showing on his two tables for the two rules. Okay, so we answered their first question. If not, can you describe where the point of intersection is? Now, one of the things you have to think of is points of intersection happen. Let me go back up to the picture we already have done. Points of intersection are going to happen where the two lines trade spots. What used to be above becomes below, What used to be a below becomes above, and you can see it here. See, the red line was below the blue one, right? And then they hit this spot, and now the red's above. Okay. So points of intersection happen when you're looking at the information on your tables, right? And you get to a spot where they change positions. So let's look. So we're looking at this two table of values. If you notice the top one, negative, 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 and the bottom one, positive, 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 right? That means the top one was lower because negatives are smaller than positives until right here. All of a sudden, between 1 and 2, the first rule became higher than the second rule, right? Can you see that? That up until between x of 1 and x of 2, the first table has lower numbers than the second table. Yes? Up until between 1 and 2, the first number had smaller numbers than the second table. Do you guys see that? So that means they must have crossed, they must have been the same between those 2 points, between 1 and 2. So somewhere between x of 1 and x of 2, their y became the same number. Somewhere between x of 1 and x of 2, their y became the same number. Okay. So if not, can you describe where the point of intersection is? So where do we believe the point of intersection is going to be? We think the point of intersection will be between what? What did we just figure out? X equals what and x equals what? X equals 1. Don't say 1, 1, just says x of 1 and x equals 2. That's where we believe the point of intersection is going to happen. Some fraction of a point between x of 1 and x of 2. We don't know how much. We don't know what it's going to be. But just going from a table of values, it's tricky. Okay. So then now we're going to graph this information on the table of values. Okay. We're going to graph his information on the table of values. Okay. We're going to graph his information on the table of values. So let me, 1 second. But I don't want to put all of them. I just need like 3 from each of the tables. So I'm going to look at -1, 0, +1. That'll get me 3 points for each one. All right. We only need 3 to make the line. Okay, so for the first one, make my dot, my 4. I'm going to make it a blue one. This is going to be my blue line. And this one's going to be my red line. All right. So on my blue line at -1, it's -10. So -1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -10. Okay. Oops. Forgot to touch it. No, this is this one. -1, -10. Oh, now I have to count it again. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. -1, -10. 0, what? I look. 0, -6. 1, 2, 3, 4, 5, 6. And then +1, what? What was with my +1? negative 2. So positive 1, negative 2. There's my, oops, we're going to change this. I just did the, watch. Make you the red one, because I graphed you. Make you the blue one. So let's go do the blue one. We're going to do the same thing. Negative 1, positive 5. Negative 1, 1, 2, 3, 4, 5, positive 5. 0 says what? 0, 3. Just wait. I got to talk to you. Let me get these last dots on and then we'll talk real quick and go. And then our positive 1 was positive 1. Okay. So I'm going to stay. I'm going to finish this graph. I am going to finish solving this rule. I'm going to continue the recording. I'm going to then post the recording, and you are going to be expected to get it finished by 6 p.m. tonight. It won't post until about 2:30. Okay. So the due date in Google Classroom is going to change, okay, to 6 p.m. tonight. So before 6 p.m., you're going to turn it in, okay? But I am going to stay, and I'm going to finish it on recording right now and post this recording. So you may stay and work with me, or you may go and watch the video later to finish. It is entirely up to you. So I have to connect my points. Make my line for both of them. That's horrible at the end, but whatever. And I have to put my coordinates on for both of them. And 0, 3. And 1. And we see that it looks like our point of intersection might be a little above the line right there between 1 and 2. Okay? Like we expected, between 1 and 2. Now we're going to go use the equations, though, like we just did down here when we solved for it with the equations. We're going to use our 2 equations to finish up. We are going to figure out when 4x minus 6 is equal to negative 2x plus 3. We're going to go solve that. Okay, we're going to go solve that. So put our balance beam in, right? Look and see. Always move the small letters to the big letters. Negative 2 is smaller than positive 4x. So what would I do to get that negative 2 zeroed out? What do I do to get that negative 2 zeroed out? We'd add 2x to both sides, exactly. Okay, what I do on the left, I have to do on the right, so I'm just going to copy and paste. Right? That is zeroed. What is our equation going to say now? Solve it up. Yep, 6x minus 6 is equal to 3. Good job. Okay, so then are we done with our addition and subtraction? Are we done with our big zeros? No. So we have to move our number away from our letter side. So what are we going to do to big zero that 6 out of there? Okay, add 6 to both sides. Yeah, good job. Okay, so let's fix that so it's a little more neat. Okay. What's it going to say? What's the left-hand side now going to become? What's the right-hand side now going to become? Okay, 6x has to equal 9. Yep. Okay. Have we handled all the addition and subtraction? Yeah, so now we're going to have to get rid of and do the big one. So the 6 has got to go. What do we got to do to make that 6 go? Okay, divide both sides by 6. So 6x divided by 6 has to equal the 9 divided by the 6, right? And we know that those 6's became 1, and 1 is unimportant, so we don't have to write them anymore. So that is an x equal to. Now, is that fraction simplest form? No. What can I divide the top and the bottom by to make it simpler? Yeah, we can divide the top and bottom by 3. Exactly. So let's divide the top and bottom by 3 to tell us what the simplest form is going to be. What would it be? 3 over 2. Now, is that between 1 and 2? Bigger than 1, but smaller than 2? Because 1 would be 2 over 2, right? It's the number 1. 2 over 2 is the number 1. And 2 is 4 over 2. So isn't 3 over 2 between those? Yes. Okay, so we know that it came between 1 and 2 like we were expecting. But we have to go use this x back in one of the equations. And we're going to replace the x with it. And it doesn't matter which one you choose. It doesn't. They will both get you the same answer because remember we were figuring out where they were equal to each other. So I'm going to pick the one y equals 4x minus 6, but it doesn't matter. It doesn't matter. Okay, I'm going to use that equation and put this x in for the x to figure out what the y has to be to make this work. So y is still there because we're solving for it. 4 over 1, because we need it to be a fraction, because the x is a 3 over 2. Remember, we did these last week and we made them look like fractions so that it kept the look for us, right? That's why we did them. Now, can the 2 simplify the 4? Can the 2 simplify? Yes. So 2 divided by 2, that's the number 1. I don't care. 4 divided by 2. What's that become then if it's not a 4 anymore? 2. Mm-hmm. So this says 2 times 3. Okay. What is 2 times 3? 6. And then we are supposed to subtract 6. So actually, the point they met is when y equals what? Y equals 0. So we have to make it a coordinate. We have to make it the parentheses. So x and y, parentheses. That's our final answer, is always going to be a parentheses answer. So what was the x that we just used, that we figured out? No, what was the x that we figured out? That we solved for? Yes, 3/2. And 0 is what happened when we used it, right? This 3/2, 0 is the point of intersection. That is the answer to the equation. That's the answer to the system. When x is 3/2, it will make y 0 and the lines meet. And if you look at it, that's what we were thinking might have happened, but we weren't comfortable with how we drew our line, right? It looked like it might have been on the X line, but we weren't 100% comfortable. So we didn't want to perfectly write it on the X line and throw ourselves off. All right. Any questions before I shut it down? Great job staying with it. Okay. So any questions, anything you need me to leave up? What? Because technically, since you guys stayed, you should have got it all finished and you get to turn it in now and not worry about it. So do you have any questions for me that you want me to clarify? Okay. So 34C was our solving for the other system. You didn't quite get it? Okay. Okay, I'm going to stop the video, but leave the share. Okay.